In order to understand the concept of Lillieforce test for normality, that is a non-parametric test that may be used to test the assumption of normality for the sample data. So students, I will be giving you a practical demonstration by taking a sample data and we would be testing it for normality using the Lillieforce test. The problem in hand is the data which shows the time in seconds that it took the sample of 16 assembly line employees to perform a certain operation. So can we conclude that the time required for the population of assembly line employees to perform the operations are not normally distributed at alpha 0.05? So students, the first thing you need to do is to arrange the data from the smallest to the largest observation, and then we would follow the formal procedure. So under the procedure, we assume under H0 that the sample population is normally distributed, whereas under H1, we would be assuming the statement that is being given to us that the sample population may not be normally distributed. Alpha was given to us as 5%. Under test statistic, we need to calculate the maximum possible vertical difference between the empirical cumulative function and that of the standardized cumulative function. But before that, we need to calculate the sample mean and the sample standard deviation. So student, sample mean is being calculated using the formula summation x over n, and it is being obtained as 7.7375, whereas the standard deviation is the sum of the square of deviation divided by n minus 1, taking its positive square root. We would be getting the standard deviation as 1.4966. Now we'll be making use of this mean and sample standard deviation to calculate the standard normal distribution through which we can calculate the standardized cumulative function. So students, as you can see, the first column here it is x. I have arranged this data from smallest value to the largest observation, and then I have calculated the z. Ab z, student, as you are familiar with the z stands for the standard normal distribution, और इसका formula आपके पास होता है z equal to x minus x bar divided by s. So students, ये देखिए आपके पास x bar है that you have obtained from your sample. This is the standard deviation, sample standard deviation that you have calculated for the sample. So पहली value जब आप डालेंगे इसमें 5.2 minus 7.7375 divided by 1.4966, it will give you the value as minus 1.70. So students, as you know that standard normal distribution may minus 1.70 is the same as 1.70 due to the symmetry of the distribution because the values are equidistant from their mean. अब इस minus 1.70 को आप standard normal table में locate करेंगे. So I'm going to share that table with you. This table is the standard normal table from 0 to z. So students, ये 0 to z तक का आपको area table given है. यहाँ पे आप 1.70 को locate करेंगे and it is being given as 0.4554. Now as you know that capital F of x is defined as probability capital X less than or equal to small x. अब अगर आप normal distribution को draw करें तो ये एरिया आपको स्टूडेंट्स गिवन है. अकॉर्डिंग टू दिस फॉर्मूला यू आर रिक्वायर्ड टू कैलकुलेट दिस पर्टिकुलर प्रोबेबिलिटी दैट इज लेस देन और इक्वल टू एक्स. अब आपको स्टूडेंट्स ये जो मैंने शेयर किया है टेबल, स्टैंड नॉर्मल टेबल, ये आपको दे रहा है 0 से, अगर इसको हम z कंसिडर करें, 0 से z तक की वैल्यू. अब आपके पास जो टोटल एरिया अंडर वन रीजन जो होता है नॉर्मल डिस्ट्रीब्यूशन में, that is equal to 0.5. आपको जो स्टूडेंट्स एरिया टोटल है यहाँ से यहाँ तक का, यानी 0 से इन्फिनिटी का, वो 0.5 है, जबकि आपको जो एरिया टेबल में वैल्यू गिवन होती है वो है 0 to z. सो इन ऑर्डर टू डिटरमिन द क्यूमुलेटिव फंक्शन, आपको ये जो प्रोबेबिलिटी गिवन है इसको 0.5 में से माइनस करना है टू गेट द रिक्वायर्ड वैल्यू ऑफ द क्यूमुलेटिव फंक्शन. सो मैंने यही किया है, 1.7 को 0 में देखा, मेरे पास जो वैल्यू आ रही है जो कि अभी हमने टेबल में लोकेट की एज 0.4554, इसको मैंने 0.5 में से माइनस किया. सो सब्ट्रैक्ट करने पे आई हैव गॉट द वैल्यू एज 0.0446. Similarly, you will be calculating all the values of z. You will locate them in the table, standard normal table from 0 to z. 0.5 area minus करने के बाद आपको ये desired cumulative functions, standardized cumulative functions मिलेंगे. Once you are done with that, your next objective is to calculate s of x, which is your empirical cumulative function. अब स्टूडेंट्स मैंने इसके बाद जो कॉलम कंस्ट्रक्ट किया है that is of frequency. So as you can observe in your data that 5.2 was appearing once, 5.8 was appearing once, whereas 6.4 was appearing twice. Similarly, the rest of the values, they appear once in the data. After constructing this frequency column, जो इसका basic objective था, that we are going to use this frequency to convert it to cumulative frequency, because using this cumulative frequency, students, we are going to obtain the empirical cumulative function. So इसको मैं cumulative frequencies की calculate करने जा रही हूँ 1 से पीछे, क्योंकि there is no value as such. So आप 1 ही copy करेंगे यहाँ पे. उसके बाद 1 plus 1 will give you 2. Then 1 plus 1 plus 2 will give you 4. So आप successively cumulate करते जा रहे हैं अपनी frequencies को in order to get the empirical cumulative function. So अब empirical cumulative function निकालने के लिए आप सबसे पहले क्या करेंगे? Students, as the total number of values was 16. So जो last value of the cumulative function है आपके पास, that will be equal to your sample size. अब ये s of x calculate करने के लिए आप क्या करेंगे? 1 divided by 16. So ये आपको first आपकी empirical cumulative function की value देगा. Then you will have 2 by 16. Then you will have 4 by 16 and so on. 16 by 16 will give you a value of 1. Once you are done with that, then the last thing you need to do is to calculate the difference between the empirical cumulative function and that of the standardized cumulative function. So students, अगर आप इसको मैं पीछे मूव कर रही हूँ, ये आपके पास था 0.0625 minus 0.0446. So upon calculating the difference, you have got 0.0179. Once you have completed the entire column by subtracting the empirical cumulative function from that of the standardized cumulative function, if you remember, we need to calculate D. और students, D calculate करने के लिए आपको supremum of the absolute difference find करना है. अगर आप इनके absolute ले लें, तो negative values will be converted into the positive ones. And after taking the absolute values, you need to calculate the maximum possible vertical distance. So students, अगर इसको हम scan करें, तो हमें जो maximum possible difference नजर आ रहा है, even after taking the absolute of the negative values, it is 0.1766. So this will be assigned to our D. So once we are done with the calculation, the last part is to compare this calculated value with that of the critical value that you will obtain from the table of critical values for Lillieforce test for normality. So students, I've shared one of the portion of that test with you so that you can locate your critical value from this table. So students, we have n equal to 16. As you can follow this table, यहाँ पे आपको row wise नजर आ रहे हैं sample size और आपको column wise नजर आ रही हैं probabilities. So for alpha 0.05 and for n equal to 16, the value is 0.213. So आपके पास जो critical value आ गई है, that is 0.213. Now under critical region, you have decided upon that you will reject H0 if your computed value of D will be greater than this tabulated value of 0.213. Since your calculated value was 0.1766, which is not greater than your calculated critical value 0.213, so H0 will be accepted and we may conclude that the sampled observations may have been drawn from the normal population.